Welcome to another session about concurrent programming in Java. In this session, we'll be discussing about the executor framework, executors framework, and we have few demonstrations available and also a session on theory about the executor. So the executor framework helps you with thread creation, thread management, and task submission and execution. So executor framework helps you with thread creation, thread management, and task submission and execution. The executors framework provides various methods for creating threads, more specifically a pool of threads that your application can use to run tasks concurrently. And also the thread management. It manages the lifecycle of threads in the thread pool, and you don't need to worry about whether the threads in the thread pool are active or busy or dead or before submitting a task for execution. And also task submission and execution. So the framework provides methods for submitting tasks for execution in the thread pool. So this is the example. So if you get the full code, so we have a public class executors demo, and inside the main method we get the current thread and print it, and we have put the output saying is out creating executor service, and next we create executor service. So here we'll create, so if we have executor service, you can see executor service. We click this, so this is the Java code, the documentation. So public interface executor service, which extends executor. So this is the executor interface. Executor service. And here we create an instance, and then executors dot new single. So if we have executors, we can see the this method several. We are creating new single executor. New single thread executor. So we have that. This is public static executor service, new single thread executor. Creates an executor that uses a single worker thread operating off an unbounded queue. So you can see the documentation available. Tasks are guaranteed to execute sequentially, and no more than one task will be activated at any time at any given time. So tasks are guaranteed to execute sequentially, and no more than one task will be active at any given time. So it creates an executor that uses a single worker thread operating off an unbounded queue. So we have the new single thread executor, and then we sys out creating a runnable, and we create runnable. So thread creation we covered in previous sessions. So this part has nothing new, and we have a logger as well. So inside this, so for now we remove this one. Right, so this is the code. So we'll remove this. Right, so we keep the code simple. We have executors demo, and inside the main method we have thread.currentThread get name, and we have the executor service here. We create new single thread executor, and we're creating a runnable object, and we are submitting it here. So we submit the task specified by the runnable to the executor service. So we can cut this code. Right, if we run this application, and we have get the same code again. So we have the code here. We have public class executors demo and the same code that we discussed previously, and we print the system out and we create executor service here in this line which is highlighted. And next we have the runnable object and we submit it to the executor service. So once we run this application, so first it prints inside main thread. So if we get thread dot current thread get name, we get the main, and next this sysout is system.out.println is executed, creating executor service, and next creating a runnable. And now you can see submit the task specified by the runnable to the executor service. And once the task is submitted, now you can see the code inside here is executed. So once the runnable object is submitted, so the code inside that is execute the run is, and it means thread dot current thread dot get name. So you can see the new thread 1. So it has the id thread 1, previous thread was main, and the new thread that is created thread 1 and it's pool 1. So if we have another thread, let's call it runnable 1, and we add another one, and if we run it, you can see once this is over the other thread will run it. So if we have sleep, put the try catch block, and if we run it, we can see, let's see what happens. So now you can see submit the task specified by the runnable thread. So inside this, and once that is executed, the next is executed. So if we run it again, so if we increase this time, you can clearly see we have two runnable objects with the same code. So inside pool 1 thread 1, so only one thread has executed, so other one it's waiting. So if we take this line, and put it after this. Inside main, creating executor service, creating runnable, submit the task specified by the runnable into the executor service. And now you can see we have two threads, two runnable objects submitted, runnable. So let's call this runnable 1, and let's call this runnable 2, and we add runnable 1 and runnable 2. So we have two runnable objects now. So we modified the code. So we have the executor service, and this is the code again. You can look at this again. We have two runnable objects, runnable 1, runnable 2, and we submit it here. And we have a thread.sleep, and remember we have executor service. We got executors.new single thread executor, so it has only one. So inside the main, creating executor service, creating a runnable, submit the task specified by the runnable to the executor service, and it goes here. And now the sleep method is executed. So we can see this line is not printed. Since only one thread can be there, you can see this runnable object is not getting a chance. So it is not getting a chance. So you can clearly see. So if you look at carefully this code, and now you can see this line is not executed due to this thread resistance. And now you can see after the sleep method, inside this line is executed here, and after that this is executed. So if you run it again, you can see the delay. So now you can see the delay again. So after some time only, once the sleep method is executed, the thread of sleep has gone, then has completed it, then only this system.out.line and also this will be executed. So the reason is we have during the executor service we have used new single thread executor. So new single thread executor creates an executor that uses a single worker thread operating off an unbounded queue. So single worker thread will be there. So if we change it, so now you can see after the delay it prints. So if you change it, new fixed thread pool. So if we have 2, so we clear this, and if we run it again, the same code, so now you can see the thread 2 is executed. It does not wait till thread 1 completes because we have a thread pool size of 2. So previously we only one worker thread, now we can have 2 threads. So since we have the pool size of 2, from this line we used executors dot new fixed thread pool 2. You can see although the first thread is executed and it is in the sleep mode, the second thread has the chance to execute and it prints inside pool 1 thread 2. Inside pool 1 thread 2. So the runnable 2 which we submitted the here is executed, and once the sleep method is executed, you can see thread 1 is executed. So if we run it again, so you can clearly see the difference if we have single worker thread, and also now we have used new fixed thread pool. We have a pool size of 2. So now you can see, although the first thread is in the waiting state, the second one gets a chance and it prints inside pool 1 thread 2, and after some time the other thread will finish the sleep method and print. So in contrast, if we have the previous way, the second thread will not get a chance to execute because the pool size is not 2, so the pool size is for the single worker thread, so the second thread is blocked or will not get a chance to execute. Now we have new fixed thread pool 2, so now we have the second thread will get a chance to execute although the first thread is in the sleep mode, and once the sleep method is over, so it prints. So you can carefully see the difference, and also it is recommended to type this code and play with the code and change these variables and see. So you can pause the video here and there and examine the code carefully and also the output. So it is recommended to watch this video several times so you can easily understand. Thank you very much. That's the end of the demonstration. Thank you.